Hello everyone. So today we are going to understand what is factor design pattern. So it is a creational design pattern that provides interface for creating objects of similar type. So this is also one of the design pattern which is most used in the industry. And before understanding where to use and how it is implemented, we would first see that what problems we were facing without using this pattern. So let's see that first. So let's understand that we have an e-commerce application where a user places an order. So once an order gets placed, the notifications need to be sent out to the users based on their preferences. The preferences could be like the user has opted for sending out an email notification or an SMS notification. So based on the preferences, the notification would be sent to the respective user that the order has been placed successfully, right? Now we'll see this example that if we are not using factory design pattern, how this is implemented and what problems we could face, and to avoid those problems, how this pattern is useful with in that same example. So first let's go through what are the problems with the implementation without this factor design pattern. So every time on adding a new notification channel, need to modify the core logic of notification service class. What does this pointer mean? So now, as I mentioned that based on the user preferences, the notification would be sent to the respective user that the order has been placed successfully. Now, let's say in future, if user wants that it needs to have some more notification type, let's say a phone notification or any such XYZ notification through which they need to get notified, requirement needs to be fulfilled in our application. So we would need to have another service which will be we need to create the another service. We'll need to have the custom logic of sending the notification in that service. This might not be clear right now. We'll see in the code what I meant by this, but the thing is like the code which we would be writing without factor pattern would not be uh, following the open close principle. So basically it will, whenever there will be new requirement coming to our application, we need to keep changing our code logic. Now let's understand this basic two pointers. The pointer number one, that we need to modify the core logic and it violates the closed open closed principle using the example. So as I mentioned that we have an order service application where a user places an order, and on successfully placement of that order, we need to send the notification to the user based on the user preferences. Let's say the user preference for now was email notification. So what we did was in our code is we created a class email notification. We wrote the custom send method. Here I've just kept the print ln statement for understanding, but this might hold the custom logic of sending the notification to the respective user. And let's say in future there was a new requirement of getting and let's say SMS notification for that particular user that has like user has set the preference of having the SMS notification as well. So what we'll do is we'll go ahead and create a class SMS notification. We'll have the custom logic of send method inside this, and we'll implement that as well. Now let's say how this gets implemented in our application. So we will expose the notification, send a notification API to the client. Okay, now, how this logic is handled. So here we are handling the logic based on the type and the message. So type is nothing but, let's say it is an email notification type or SMS notification type, and message is nothing but the message we will send while triggering that notification for that particular user. So now let's say we were having just two preferences set by that user, which is email and SMS. We were fine. We handled that in if else logic here, that if the type is email, that is the notification type is email, then we'll create an email notifications object and we'll trigger the send method. So what does this line do is 4 and 5. It will go when this line number 4 will return an object of email notification class which we have created this, and it will in line number 5 it will trigger this send method. Okay, so so far it looks fine. Now let's say there was some new preferences set by the user. They say that let's say I want some new XYZ notification which needs to be sent to me whenever I place an order. So first thing is we need to modify this logic of notification service class. That is, we will have to add one more else if statement. where it will handle that type of the notification, the new notification type. And we will need to call again the notification, like we need to create a separate new notification service class again for that. And we need to send the notification based on the type which the user has mentioned, or whatever the requirement is from the user perspective, right? So this will like grow. There will be multiple if else in this code if there are more and more number of requirements coming up. So this does not look good, and this is also not easy to maintain. So if there is any change in this logic, we need to test all the test cases for the other type of the notification. And so testing also becomes a bit cumbersome here, and it's not easy to maintain. The code is not extensible. So basically, it does not follow open closed principle. Like, so this does not seem a good way of implementing this, and hence we will go ahead and implement the same example using a factory design pattern. Now let's see how that is implemented. Before saying that, we will understand the class diagram, and then I'll explain the same into the code as well. So first, let's understand when to use this pattern. So let's say there is a need to create a type of object at the runtime. We will go ahead by using this pattern. And when we have object creation logic bit complex, repetitive, and it requires encapsulation, we'll go ahead with this design pattern. Let's understand the class diagram for the same. So by implementing that same example, how we will modify it and incorporate this factor design pattern here, so that in future our code is open for extension and closed for modification. It won't have a cumbersome if else logic inside it, and it will be easy to maintain and easy to test. So first we'll create a notification interface. So this interface will hold one method which is known as send, and will have a parameter message, and its return type will be void. So whatever the type of notification would be in our system, we will be implementing this interface, and there will be custom logic for that particular notification present in that respective send methods. So what is this abstract notification creator class? So in the naive approach, we were trying to handle whatever the new notification type or the type which is existing in a system based on the type parameter. We were creating the instance of this notifications, whatever based on the type it is, and we were calling the send method of the respective notification, right? So now how this notification creator will work in this scenario is, first thing is we want to avoid that if else logic. So for what we will do here is, whenever and this two are the this is an abstract class, so create notification is an abstract method which will be implemented by both of this class who are extending from this notification creator class. So now whenever we will be calling the send method, okay, so whenever a send method would be called by the respective like whatever the send method is getting called from the whatever the APIs will be exposing to our client. So from there, how will this work is, the send method will call this create notifications method based on the whatever the instance it is calling. So let's say if email notification creator is calling the create notification, its responsibility would be to return a type notification. So it will return the instance of this email notification type, right? And based on the returned instance, it will, using that instance, it will go ahead and call this method. Same way for SMS notification as well. So this is how it will work. So to better understand this, let's go and see how it is implemented in the code. And I'll keep this diagram on the left right hand side, and the code will, I'll keep it on the left hand side for better understanding. So let's see that. So the interface notification is nothing but we have created the same interface notification. We have the method send with one parameter, which is the message which needs to be sent when this method is getting triggered. So as this is an interface, the email notification and the SMS notification will be implementing this interface and have the custom logic of send implemented there. So here I've just kept the println statement for the understanding purpose, but it will hold the custom logic here. So this email notification implements this notification interface and it gives the logic for the send method. So here we have kept the println statement as sending the notification for whatever the message we are getting, right? Now let's understand this notification creator, and same it goes for SMS. And now let's see what is this notification creator abstract class. So for that, this is the abstract class as I mentioned, and this create notification is an abstract method in this class. Now, whatever this class is, email notification creator and SMS notification creator, which are extending this class, abstract class, will give its implementation of create notification there. Okay, and this is the send method which is present in the notification creator class. So first let's understand this email notification creator class, which is extending this abstract class. So as I mentioned that, like whatever this class, email notification creator and SMS notification creator, its responsibility is to return the instance of this email notification and the SMS notification respectively. So here in create notification, it will return the instance of email notification. Okay, so this, like whenever a send method is getting hit, this is something which we'll be exposing to our client. So whenever send is getting called with the message, first it will go ahead and call this create notification. So let's say if an email notification creator dot send is called, so it will go ahead and call this. This is nothing but whatever the instance which is calling the send method. It will go ahead and trigger its create notification. In this instance, it will go ahead and create trigger this one. It will return the type of the notification, respective email notification, which is the instance of this type. And using that instance, it will go ahead and call the send method. So this notification is nothing but an instance of email notification. So when this dot send is called, so it will go ahead and call basically this send method is getting called, right? So this is how this notification creator is implemented. So how this implementation is helpful as compared to the naive approaches. So here we are not concerned about, like, we will not modify anything in the send method, right, which will be exposing to our client. So we'll not have to handle whatever if else we were handling. So this does not has to handle that. So let's say in future we have some new notification type getting added to our system. So how it will work is it will go ahead and implement this interface send method first thing, because there is new notification type getting included, and a notification creator, like whatever the notification new notification type is getting created, the similar notification creator would also get implemented, and that would extend this abstract class, and its responsibility again would be to return the type of that notification which newly got added, right? And based on that type, it will go ahead and call the send method of the new notification type. So this becomes easy to maintain. It is like open for extension and closed for modification. So basically, we are never going ahead and modifying the send method. It's like we are, if anything is coming in future, we just have to go and implement that interface notification, and we have to create a new class of that particular notification known as the XYZ notification creator. Its responsibility would be to return the instance of that newly notification which got included in, or which got into our new application. Simple enough, right? Now let's run this from the main and see. So in the main, it's nothing but we'll have an instance of notification creator, right? That is what something we'll be exposing to our client. And let's say we are calling the email, we want to send the email type of notification. We'll have the notifications creator. This is nothing but it will go ahead and call this send method, right? And with this, the send method is nothing but it is just holding the message. This is something but this one. This send method is getting called. And yes, so based on that send method, respective notification will get triggered. So let's run this. And yeah, so whenever we called this, let's see this. This is loggers are getting printed. So whenever the send method is getting called, it is going into the email notification creator class and creating the email notification instance. So this is getting called. inside email notification creator for creating the email notification, and it will return this. So once this gets returned, so like whatever this gets returned here, it will go ahead and call the send method, respectively send method. So this is that send method is implemented in this email notification. So sending notification for email. So that is what the message we have sent. Similarly for the SMS one. So this is about the code implementation. Now let's understand the key takeaways from this design pattern. So what are the key takeaways? So it separates the object creation from the business logic. So here the business logic remains separate and the object creation burden also remains separate. So what does this mean is, so whenever if there is any new notification type, as I mentioned previously as well, is getting added, the only change we are making in our code would be going ahead and implementing the notification interface, right? And creating the respective creator for that same, whose responsibility would be to return the instance of that new notification which is getting added into our system, right? The send method does not get modified anywhere. So it has a separate, everything is everything is not tightly coupled. It's like it reduces the tight coupling of the concrete classes. That's what our second point is, reduces the tight coupling to concrete classes. It makes our code easier to maintain, and it becomes easy to extend as well if required in the future. It simplifies adding the new notification type, as I mentioned previously as well, and it also improves the testability and the readability. Right? This is all about this design pattern. I hope you like the content. If you like the content, do like, share, and subscribe, and follow for more for some new interesting content. Till then, bye bye, take care, and have a nice day.